in an aeroplane's takeoff sequence. A plane hits 6 critical speeds during takeoff. The first is the stall speed. This is the minimum speed at which a plane will remain airborne. This is not used as the takeoff speed, as any decrease in speed due to fluctuations in wind or orientation of the plane will cause the plane to fall. The next critical speed is the minimum control speed. This applies to multi-engined aircraft only. If a multi-engined aircraft loses an engine, the uneven thrust between the wings will cause the plane to turn. This is called yaw in aviation. To counteract this, the rudder will be deflected to provide the opposite yawing moment. The rudder needs air passing over it to work, and thus the minimum control velocity is the velocity at which the rudder can provide enough of a yawing moment to keep the plane straight in the event of an engine failure. The next speed a pilot needs to worry about is V1. V1 is a line in the sand for pilots making decisions whether to abort a takeoff. If something happens before V1, like an engine failure, the pilot must abort the takeoff. If it happens above V1, they must continue with the takeoff, as it would be unsafe to stop. This is the most important speed for runway designers. At this speed, the plane will need enough distance on the runway to safely bring the plane to a stop, which is exactly the same as the distance needed to reach V1. The resulting total runway length is thus called the balanced field length. Back to that in a moment. The fourth critical speed is VR, or the rotation speed. This is the point the plane can begin to lift its nose and begin its ascent. The next speed, which results in some of the coolest testing videos, is the minimum unstick speed. This is the speed the plane can take off at its maximum pitch, which is actually the point where the tail skid hits the ground. And this is a video of a test pilot testing that speed. Since this would be incredibly uncomfortable, the actual takeoff speed is at least 10% higher than the minimum unstick speed. At this point, no part of the plane is touching the ground and it is officially airborne. It must then accelerate to its climb speed, V2, which it must achieve with a minimum clearance of 10 meters from any obstacle.